All right, for chapter 5, we're going to start higher order polynomials. Basically, these are polynomials with exponents greater than 2. You're used to linears, which just basically have an x. You're used to quadratics, which have an x squared. But now we're going to do x cubed, x to the fourth, x to the fraction. We're going to do all sorts of random stuff like that. But to start off, we need to discuss what is and is not a polynomial. A polynomial basically has x to a number. Okay? That number can be as simple like a 2. It can be a fraction. It can be a radical, x to the square root of 7. It can be x to the pi. It can be whatever you want it to be, so long as it is an actual number. What does not constitute a polynomial is basically when you have anything x anywhere else. So if I have like x as an exponent, that is not a polynomial. If you have x as a in the denominator, this is not a polynomial. If you have x in a logarithm, which we'll talk about logarithms later on this year, that is not a logarithm. That is not a polynomial. X can be under a radical, because we'll talk about later, a radical is nothing more than a fractional exponent. All right? So, bottom line is this. It has to be x to the power of an actual number. Okay? So, without further ado, number one. Number one, is this a polynomial? Yes. For the simple answer, all of your x values are simply raised, all your variables are simply raised to a number. So let's start off, let's write this in standard form. Standard form basically means put the exponents in order. That's all that means. So in this case, we've got f of x equals negative 3/4 x. We'll put the fourth first, plus 2x squared. We put the squared second, plus 6x, plus 1. All right? So that's in standard form. The exponents are in order for standard form. If not, why? Well, we don't have to talk about that, because it is. The degree. Degree essentially means, let's do it over here. Degree equals highest exponent. So this one, the highest exponent is a 4. So the degree for number 1 is 4. Okay? The degree for number 1 is 4. For a quadratic, when you have stuff like, what we've been dealing with before now. Come on. We got like x squared plus x plus 1. That's all have a degree of 2. When we were dealing with lines, we got y equals 1/2 x plus 5. That is a degree of 1 because there's a little 1 right there. All right? That is the highest exponent that x has. The type. This simply just basically means what kind of polynomial this is. Is it linear? Is it quadratic? Is it cubic? This one's actually the highest degree is 4. So we call it a quartic. This is a quartic polynomial. That's not as important, but we're just trying to get you to see. Last but not least, the leading coefficient. The leading coefficient. That is basically what is the coefficient in front of the highest exponent? The leading coefficient. So, in this case, it is negative 3. Okay? And that leading coefficient actually tells you a lot about the graph. It tells you which way it's opening. Is it opening up? Is it opening down? It talks about end behavior, which we'll talk about that later on. But that leading coefficient will become important later. So you have to be able to identify the degree and the leading coefficient. Okay? Now, I spent a lot of time on number 1. The rest of these, I'm just going to kind of try and burn through pretty quick. But I think you'll pick up on it very fast. All right, so number 2. Is this one a polynomial? The answer is no. The answer is no. Why? X has an exponent right there, but x is in the denominator right here. We cannot have x in a denominator. So this is not a polynomial. If not, why? X cannot be in the denominator. Denominator. Okay? This is actually, if x is in the denominator, that becomes a rational function, which we'll talk about later in the year. But for a polynomial, x cannot be in the denominator. So, let's keep on rolling from here. Number 3, the question, is this one a polynomial? The answer is yes, this one is a polynomial. Yes, it has a fractional exponent, that's okay. This one also has an exponent of 1, so what if it's multiplied by the square root of 15? Who really cares? But this one is still a polynomial. So let's put this in standard form. So in this case, we've got g of x equals, the highest exponent is 1, which is right there. So it's x to the square root of 15 plus x to the 1/4 plus the square root of 5. All right. So this one's a polynomial. That's standard form. The exponents are in descending order. The degree for this one is, if you haven't guessed it already, the degree is 1, because the highest exponent is 1. Now this one isn't linear, simply because of this bad boy right there. If that wasn't there, this would be linear, but it's not. The type, this one really, we wouldn't call this anything. It would be linear, like I said, except for that, but I'm not going to worry about that as much. Leading coefficient. The leading coefficient for this one is actually the square root of 15, because the highest degree is being multiplied by the square root of 15. That may throw you because of where it's written, but it's just, normally you'd write the numbers in front. Normally you'd write the numbers in front, like 3x. But with a radical, we always put it behind. It's the same thing. We just don't ever write the square root of something times x, because it's very easy to confuse it and think, oh, the square root goes over that as well. So if that threw you, I'm sorry, but just what it is. All right, number 4, last one. Is this one a polynomial? Yes, it is. All the variables only have numerical exponents. There's nothing funky, nothing in the denominator, nothing funky like that. Funky. So let's write it as in standard form. So p of x equals 2x squared plus 3x minus 2 on the square root of 3. And if you want to take a second pause, just fill out the rest. That would be a great idea. But here we go. If not, why? Don't need to talk about that. Highest degree, 2. That is the highest exponent right there. Type. This one, the highest one is a squared, so this one is a quadratic. We've been talking about these already. Quadratic. And the leading coefficient is 2, because that is the number in front of the highest degree.